Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at multi-access OSPF networks. We'll be discussing OSPF network types, OSPF designated router, OSPF multiple access reference topology. We're going to verify our OSPF router roles and BDR adjacencies. We're going to look at DR failover and recovery. And finally, we're going to talk about the IP OSPF priority command. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. Another type of network that uses OSPF is the multicast OSPF network. What this multicast OSPF networks are is one router controls the distribution of all the link state advertisements. It controls where all those link state advertisements go and how many we're sending out, keeping the number down of actual link state advertisements that need to be sent out versus where there is none that are controlling that. Here in our example, we have 4 routers. Those 4 routers are connected to an Ethernet. They all form adjacencies with each other. They're all sending out link state advertisements. If there was one router that controlled those link state advertisements, that would be one point of contact to get that information. And that's where this election of the designated router and backup designated router happens, that election process. To decide who controls those messages, we go through that election process. That election process uses the router ID. There's 3 ways to set the router ID. First way is, did the administrator set a router ID? Did you, as the administrator, go in and explicitly set that router ID? If there's no explicit router ID set, then we use the loopback address. The highest loopback address will be the router ID for that router. If there's no loopback address, you did not set one as an administrator, we fall down to the third and final one. We use the highest IP address of all active interfaces. Even if they're not part of the OSPF process, the highest active IP address is going to become our router ID. Now, instead of relying on loopback addresses and our highest active IP addresses, I like to rig that election. I like to go in there and set my router IDs. That way I know exactly which router will become our designated router. OSPF election process gives us our designated router and our backup designated router. That designated router is that central spot for collecting and distributing our link state advertisements. It collects them, it sends them out, it gives those updates to all the other devices. That designated router uses a multicast address of 224.0.0.5 that communicates with all of the OSPF routers. So it's a special multicast address that's assigned for OSPF in the communications. The backup designated router is also elected during this process. It takes over for the designated router in case it fails. And that backup designated router, the BDR, it listens passively. Means it just listens to the information coming in. It builds its own table. It processes all that information, but it doesn't send out anything as long as it's the backup. Once we have that backup or designated router and our backup designated router, all the other OSPF routers become a druther. And do you say it's a druther? Some people say it's a DR other, depending upon where you are. I've heard them pronounced both ways. I typically say a druther. And that's a router that's neither a designated router nor a backup router. You got 5 routers in your OSPF network. One's going to be the designated router. The other one's going to be a backup designated router. You're going to have 3 other ones that will be your DR other routers. They use a multicast address of 224.0.0.6 to send OSPF packets. And so This is another special multicast address that sends, that those DR other routers send OSPF packets to the designated router and backup designated router. The only two devices that listen to that multicast address of 224.0.0.6 is our designated router and our backup designated router. Here's an example of an OSPF multi-access network. We have three routers, router 1, router 2, router 3. They're all connected to a switch, meaning they all share advertisements. They're going to form adjacencies with each other. When we connect up those devices, we activate OSPF on those connections. It's going to go through the election process. You as the administrator went through and set some router IDs up on our devices. You set on router 1, we set the router ID of 1.1.1.1 for ones. Router 2, we set up the router ID of 2.2.2.2, and on router 3, we set up the router ID of 3.3.3.3. We did that to keep it simplified. In this example, router 1 has 1.1.1.1, so we can easily identify what's happening. In your production environment, you may do it a little bit differently, but a lot of times I still see people use the 1.1.1.1, the 2.2.2.2, even though their devices probably aren't named R1 and R2, but that gives you a clear ID, clear number on which one is going to be elected as your designated router and backup designated router. Because you as the administrator went and explicitly set those router IDs, the election processes went through. The highest router ID became your designated router. That means down here on R3, router ID of 3.3.3 became our designated router. That is the control person for all advertisements for our OSPF. After we elected the designated router, then we figured out who's the backup designated router. That's the next highest router ID. Next highest router ID was on R2. That was 2.2.2.2. And so they passively listen to all link state advertisements that are going on our network. They build their own information, but they don't send out any information. That leaves our last one, our third one, with the 1.1.1. That's the lowest out of the three. This one has become our DR other. Once again, a DR other is not the designated router, not the backup designated router. To verify these OSPF router roles, we're going to look at the show IP OSPF on each one of these routers. First one we're going to look at here is router 1. Router 1, we're going to do the show IP OSPF interface gigabit Ethernet 000. That's one of our interfaces that are participating in the OSPF network. Looking through here, we have our IP address, we have our process ID, we have our router ID. Network type is a broadcast. What our cost is for our network. Down here, it says what our state is. So the state of R1 is a DR other or drother. After that, it now lists our designated router and our backup designated router. Our designated router was the highest router ID, which is 3.3.3, and that has an interface address of 192.168.1.3. That was the IP address on R3. The IP address on R3 that was part of that network that connects up all the routers, that internal network that connects to the switch. Then we list out our backup designated router, which was the second highest one, which was the 2.2.2.2, and that is the IP address 192.168.1.2. That was the gig 00 interface on R2 that connects to the switch, that multi-access network. Couple other pieces of information down here. We have the neighbor count. Our neighbor count is 2. We're on R1. And so that means we have two other neighbors. That would be R2 and R3. Adjacent neighbor count is, those are directly adjacent to us. They're directly connected. Yes, you have to go through a switch, but they are directly connected. You don't have to go through another network to get them. And then it lists out which ones is our adjacent neighbors. We have adjacency with 2.2.2 and adjacency with 3.3.3, and then it also identifies them as our BDR and DR. On R2, we're on R2 here. That's the second router. We do our show IP OSPF interfaces. We have all of our information here. Coming down here, we can see that our state is our backup designated router, our BDR. Then we get the results of the election here. We're going to state out who's our designated router, who's our backup designated router. Designated router, once again, was the highest router ID, 3.3.3. That was on R3. And then it gives us the IP address of the interface on R3. Then it lists our backup designated router, which was 2.2.2, which happens to be the current router, router 2, our router ID. And so right here, we are listing ourselves. And then we list the interface address of that, which is an interface here on R2. Our neighbor count is 2. Because we only have 3 devices, we're on one of them. That gives us our 2. And then we list our adjacencies. We're adjacent to neighbor with a router ID of 1.1.1.1. That's router 1. And then we are adjacent to neighbor with a router ID of 3.3.3, which is our designated router. We can get all of that information here from our show IP OSPF interface command. Then on R3, we can issue that same command again here on R3, show IP OSPF interface. Come down here, we can see that our state is our designated router. We list out our designated router and our backup designated router, 3.3.3, 2.2.2.2. We are the 3.3.3.3, but we're still going to list that out. We list out the IP addresses on those interfaces. Our neighbor count is still 2. We list out router 1. We list out router 2. We have our adjacency information. We have the results from our election, who our current designated router is, and our backup designated router. And we say what our state is. We are the designated router. We have verified our OSPF router roles. If you like this episode on multi-access OSPF networks and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. Subscribe to my channel and click that notification bell. You can visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. To verify your OSPF adjacencies, we can use the command show IP OSPF neighbor. And then it's going to give you a list of different states you could possibly have with the adjacencies to your different neighbors. For the full druther, this is either a DR, a designated router, or a BDR that is fully adjacent with a non-DR or a non-BR. Because remember, a DR other or a druther is an OSPF router that's not the designated router or a backup designated router. So you are one of these two. You're a designated router or a BDR, and you are directly connected to these. A full DR is a router that's fully adjacent with a designated router. So you are fully adjacent to a backup designated router. You're in these two, you're communicating with a designated router, or you're communicating with a backup designated router. That signifies your adjacency with who you're at. Now, the idea of full here, full means you are having that full conversation. And so the full means you are exchanging hello packets, you are exchanging updates, you are exchanging queries, you're exchanging replies, and you are exchanging acknowledgments. You are having a full conversation using OSPF to identify the links and the states and getting the idea of how your entire network looks. The other state of your neighbors is you could have a two-way here, and that happens between your DR others, your non-designated routers, your non-backup designated routers. And what that is they maintain in the two-way state. They are only exchanging hellos. And so here you're only exchanging hellos. Remember how OSPF works. Your designated router, your backup designated router, they maintain those full tables. They maintain those full adjacencies, a connection to all the other routers. They maintain that. They're the only ones responsible for sending up those LSAs to all the other devices. And if you're not either the designated router or backup designated router, you're that DR other, and you just maintain hellos between the other or to the other DR other devices, because you're not sending updates to them, you're not sending announcements to them, you're just making sure that they exist. And if we have to, then we can go through the election process again because we know they're there. The normal state for an OSPF router is full. But the only exception is the two-way state between the non-designated router and the non-backup designated router. When we type in show IP OSP neighbors, this is where it's going to list all of our OSPF neighbors. They're going to identify it by the router ID here. Then it's going to give us our state. And notice we have full, meaning we have full conversations with these other devices, and this adjacency is to a DR other, and this conversation is to the designated router. Router 2 had that 2.2.2.2 router ID, which after the election process made it the backup designated router. And the backup designated router holds full conversations with everybody in the network, including the designated router and other devices that aren't the designated router or the backup designated router. It lists our information for us. To do the election process for OSPF to get our designated router and our backup designated router, the default process looks at the interface with the highest priority. That becomes the designated router. The second highest interface priority, that becomes the backup designated router. Now, priorities can be anywhere between 0 and 255. If the priority is 0, and you manually went in there and set the priority as 0, that device cannot be elected as a designated router or backup designated router. Why would you want to do that? Maybe it's a high traffic device and you don't want it to handle the extra computations of sending out all of those link states and computing the tables. Maybe it's an older router. For some reason, you don't want it to do that. Now, if you don't go in and manually set it, that default priority is 1. So it takes the highest priority and sets that as a designated one. Second highest priority, that becomes your backup designated router. Now, if the priorities are all equal, the router with the highest router ID is the designated router. Okay, understand that. Interface priority, highest one gets designated router. If you don't manually change any interface priority, they're all going to default to 1, and then we use the highest router ID to give us our designated router. And then the second highest router ID would be the backup designated router ID. The election takes place when that first router turns on with an OSPF enabled interface. When that interface becomes active, that's when the election takes place. There could be a situation where the highest router ID doesn't become the designated router because it took longer to boot for some reason. Maybe it got turned on a minute later. And because of that, the router with the lower ID, which should never be elected the designated router, got elected to it because the router with the highest router ID hadn't finished booting, hadn't activated the interfaces. Because it wasn't online when the election took place, because that election starts right away when that interface becomes active, that first one becomes active, that the lowest or the highest router ID that was active at that point in time becomes the designated router. Even if a new router comes online that has a higher router ID, it will not initiate that election process. Your designated router stays the designated router until one of three scenarios happens. Your designated router is the designated router until it fails to be the designated router. Whatever the reason, it turned off, it unplugged, it caught fire, it got struck by lightning. It's no longer your designated router. Second reason it's not the designated router is that OSPF process on the designated router either fails or stops. Sometimes that OSPF process just freezes, and that's why we have our redundancy to work around it. Sometimes it just stops. Maybe your intern logged in and stopped OSPF for some reason. Don't know why, but OSPF stopped. Your designated router no longer is your designated router. Or the third reason here is that multi-access interface on that designated router fails or shuts down. Now it could fail. The electronics could die. I mean, I've seen that maybe once or twice. It's very uncommon. Somebody goes in and shuts it down. Once again, your intern went in there, shut down the wrong interface. Or the other reason, typically, that interface no longer works is somebody unplugged a cable. A backhoe cut through the fiber optics that connects them up. That interface is no longer sending or receiving data. Once one of those three scenarios happens, your designated router fails. When it fails, the backup designated router automatically takes over. It's been passively listening to all the updates, keeping track of all the routes, doing all the calculations and algorithms. That backup designated router automatically takes over. When that backup designated router becomes a designated router, we start a new election process to get a backup designated router. Any of the OSPF routers in your area that were formerly a DR other router, they can now go into election process. The highest priority or router ID is now elected the backup designated router. Interface priorities by default are a value of 1. By default, interface priorities are 1. If all of your priorities are the same, so you didn't go in there and change anything, they all went to their default of 1, then the highest router ID is elected to our designated router. I think, and industry best practices is to control that election by going in there and setting interface priorities. Interface priorities allow you to decide who's going to be that designated router. Who is going to be the person who controls all of those link state announcements and updates on your network. You want to probably pick one router over the other. Maybe the less congested, maybe the newest router. You want to set that up. Also, by setting interface priorities, that allows a router to exist and be a designated router in one network, and also a DR other in another network. You might have scenarios where you have to have that happen. This could be when you're starting to look at a multi-area OSPF. You have the router, and so you have to have interfaces in different areas To set your priority, we use the IP OSPF priority command. And that's a value between 0 and 255, 256 possible values there. Default is 1, so yeah, 1 is default. If you set the value here to 0, it's not going to participate in the election process. It will never become a designated router. It will never become a backup designated router. Maybe it's an older one. Maybe it's congested. Maybe you just want to keep all that traffic off of a router for some reason. Set that value to 0. And then the value of 1 to 255 on the interface means it's more likely that the router will become a designated router or a backup designated router. And once again, the higher the priority will become that designated router. And so if you want it to be a designated router, go ahead and set it at 255. Personally, I wouldn't make that jump straight into 255. I would say 5 or 10. That way it would allow you to, when you get a new device in there and you want that new device to force the election process to become the designated router, you can assign it a higher number. To configure our OSPF priority, what we do is we go into the actual interface where we want to set it. In our example here, we're going to go on R1, we're going to go into Gigabit Ethernet 000. When we're in that interface, we can use the IP OSPF priority command, and we can set that value. Like I said, I wouldn't necessarily jump at 255. I'd set it higher than 1, 5, 10, 100. If you set it at 255, you can't set anything higher than that. Once you set that, we can go ahead and reset all the OSPF processes, force that re-election by using the clear IP OSPF process command. That'll go through and force that re-election. And because we've set that interface priority to 255, R1 should become our designated router when the process is done. It was my pleasure to provide you with this wonderful episode on multi-access OSPF networks. If you like this episode and you got value out of it, and depending upon the platform you are using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. You can get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.